In this video, I'll be covering component state, event handling, and component lifecycles in React's class-based components. My name's Larry, and this is Digital Logic. This video is part of a series. In the first video, we set up a development environment. In the second video, we created our first app, which was the Hello World app, and learned the basics of a React component. So if you haven't set up a development environment or created a React app yet, you probably want to check out those videos first. All right, so let's get started. So I'll start out by creating a new app. I've already got a terminal open where I want to place the app, so I just need to type in npx, create React app, and then I'll call this app class event lifecycle, and then hit enter. It will take a few minutes to create the app, so just be patient. Now open up the app in your IDE. In the last two videos, I used VS Code, but from now on I'm going to be using IntelliJ. But it really doesn't matter what IDE you use, as long as it supports JavaScript. So I'm going to go ahead and open up the app.js file, and it looks like I have to set what version of Node I'm using. And let's get the development server up and running. You can open up a terminal by pressing Ctrl+ in VS Code, and then type npm run start. You can also start it from the package.js file. In VS Code, you'd have to right-click on the start script and then select run. And then open up the browser, hit F12 to open up the developer tools, and then go to the React developer tools. And you'll notice that I'm getting an error in the console. The reason is because React 18 was just recently released, and the Create React app hasn't been updated to use the new API. So back to my IDE, and then I'm going to open up the index.js file, and I'm going to update the API so we don't get that annoying error message in the console. Most likely you won't have to do this. I'm just doing it to clean up the console. So I'm going to comment out the React DOM render method, and then paste the code for the new API. Now I need to import the create root function. And then my app is using root, not app, for the element ID. Then I'll remove the tab parameter since I'm not using that. And I want this to run in strict mode during development, so I'll add the strict mode component. And then I'll check the browser console to see if I'm still getting an error message, which I'm not. So back in my IDE, I'll close the index.js file. In the app.js file, I'll delete everything between the header tags. Remove the import for the logo.svg, and import React. So now create a new class-based component named counter, and make sure it extends react.component. The only required method in a class-based component is the render method, so go ahead and add that. And then return a JSX element. Add a div tag with an h3 element, and then the text counter. And then a p tag with a static value of 0. And then add a button with the text increment. And now let's add this component to our app. Then I'll format the code, save the file, and let's check out the results in the browser. So you can see that our component is displayed, but it doesn't do anything. So let's go ahead and fix that. Back to your IDE. So the first thing that we need to do is add an internal variable that'll maintain the count for the component. To do this, add a constructor function, and then pass props to super. And then within the constructor function, I'll type this.state equals a new object. Within this object, we can define any state variables that this component requires. In this case, we only need a count variable, and I'll set its value to 0. So first let's output the current state value in the component. So I'll add curly brackets, and then type this.state.count. Save the file, and let's check the results in the browser. So of course nothing's changed in our display, but if you click on the counter component, you can see that we now have a count state variable. Now we need a way to increment the counter every time the increment button is clicked. So add a class method, and I'll name it handle increment. And then let's console log the current count value from this component state. Every time this function is called, we need to increment the count value. So I'll start by showing you the wrong way to mutate a component state. So call this .state.count and then increment the count value. Notice that the this keyword is highlighted. This is because ESLint is producing a warning message. Now we need to set up an event listener to execute this function whenever the button is clicked. So add a onClick event handler to the button, and in React, all components use camel case for properties, including event handlers. Within the curly brackets, add this.handleIncrement.bind this. I will be covering event handling in more detail later on in this video, so for now don't worry too much about it. Save the file, and then let's check the results in the browser. Notice when I click the increment button, the counter component does not update. But in the console, we can see that the value outputted is incrementing. React doesn't know that the internal state has changed, so it doesn't re-render the component. This is the most noticeable consequence of manually mutating a component state, but it does create other problems as well. Like the component state could get overwritten by a call to set state or by a lifecycle method, and then lifecycle methods could receive stale or corrupt data. And this is why you never want to manually mutate state. The proper way to update a component state is to call this.setState and then pass in a new object with the updated state values. In this case, I want to modify the count key, and I'll set it to this.state.count plus 1. And make sure that you don't increment the value here. We want to add 1 to it. Save the file, and let's check the results in the browser. I'll start by clearing the console log, and then click the increment button, and you can see that the counter works. And then click on the counter component in the developer tools so we can view the component's internal state. And notice that our console log output is always behind our current count. Why is that? The reason is because the setState method updates the state asynchronously. So when we console log out the count, we always get the older count before the update was applied. To help illustrate this, I'll duplicate the setState call so that we increment the count twice within this function. Save the file, and let's check out the results in the browser. So when I click increment, the count only increments by 1 and not 2. This is happening because the count value doesn't get updated immediately, but at some point in the near future. So both calls to setState result in setting the count value to the same thing. If you want to update a component state and you need to refer to a value in state, it's better to pass a function to the setState method. The first parameter to this function will be the component's updated state. This function needs to return an object, which will be merged with the component state object. And then update the count value using the state object passed to this function. Duplicate the call to setState so we can verify that this version works. Save the file, and let's check the results in the browser. Now when I click on the counter, you can see that the counter increments by 2. And of course, you can check the component's internal state in the React developer tools. Remove the second call to setState since we don't need it anymore. You can also destructure the state object provided to the setState method. Right now, we only have one variable, count, within this component state object. So I'll add a second key, which I'll name user, and the value will be another object. I'll add a name key with the value of Bob, and an age key with the value of 50. Save the file and open up the browser. And then click on the component in the developer tools so that we can see the component state. When I click the increment button, you can see that the count value increases. But more importantly, nothing happens to the user object. But what if we modified the user object in the handle increment function? Then I'll pass in a function to set state, and then destructure the user key. Make sure to return a new object from this function. And all I'm going to do is increase the user's age. Save the file, and let's check the results. Click on the counter component so we can view the internal state. And then notice what happens when I click the increment button. The user's name disappears. So why does this happen? The reason is because the setState method will take the new state object and perform a shallow merge with the component's existing state object. That's why we can increment the count in the first setState method without the user object disappearing. But when we try to increment the age key within the user object, the entire user object gets overwritten. To fix this, we need to make sure to copy every key value pair for any object stored in state when we try to update those state objects. And an easy way to do this is with the spread operator. The spread operator will copy all enumerable properties from the user object into a new object. Then just overwrite the properties that we want to redefine, like the age property. Save the file, and let's check out the results in the browser. Click on the counter component so we can view its internal state, and then click on the increment button, and notice that the age value increases, but the name value does not disappear. So remember, when you need to modify a component state value, always use the setState method and never modify it directly. The setState method performs a shallow merge with the component's current state object. So make sure to copy the values from any objects or arrays into a new state object with the modified values. And remember that setState runs asynchronously, and that you can pass in a function into the setState method to access the most current version of your component state object. So now let's take a look at the event handler that we've defined for the button component. Notice that the event name is camel case. All event names in React follow this pattern. Also notice the use of .bind within the onClick handler. But what would happen if I were to remove that? Save the file, and let's check out the results. When I click the increment button, we get an uncaught type error. This happens because when the handle increment function is executed by the onClick event listener, the value of this is undefined. Trying to access a property or function on undefined is always going to result in a type error. This has to do more with how JavaScript works than with React. Every function defined with the function keyword has a hidden this property, and the value of this is determined at the call site. In this case, I'm passing a method reference to the handle increment function to the onClick event listener. But when the event handler invokes this function, the value of this is lost. So instead we receive undefined. An easy solution is to use bind, which will return a new function that statically sets the value of this. Another option would be to use an arrow function. Unlike functions defined with the function keyword, arrow functions don't have a hidden this property. So when this is encountered in an arrow function, it uses lexical scoping to resolve the object. In this case, it would resolve to the current instance of the counter component, which is what we want. In either case, passing in an arrow function or the result of calling bind is not the best way to define an event handler. The reason is because every time the counter component renders, we'll be passing in a new function to the button component. Now this won't have a major impact on performance, regardless if the button component is a native component, like it is in this case, or if it was a React component. But by providing a new method reference to the onClick event listener, guarantees that the button component will re-render every time the counter component re-renders. You can avoid this by passing in the same method reference to event listeners, removing the requirement for them to update every render cycle. One way to do this is to create an instance variable, which I'll call handle increment, and I'll set it equal to the result of calling bind on the handle increment method. As we already know, bind returns a new function that statically binds the value of this to that function, enabling us to execute this new function in any context. This new function is being stored as an instance variable compared to the handle increment function, which is defined on the prototype object. Save the file, and then open up your browser to check out the results. Refresh the browser to clear the console, and when I click the increment button, you can see that the counter works. Let's console log out a new instance of the counter component. Save the file, and then open up your browser. Expand the counter object in the console, and here you can see the handle increment function, which was returned by bind. Expand the prototype object, and you can see the original handle increment function. If you don't want to use bind on your event handler, another option would be to define your event handler as an instance property that's assigned to an arrow function. So the handle increment function is now assigned to the counter instance, which means each instance will receive its own unique function. And now when I click the increment button, you can see that it still works. You can also define your component state using this syntax, and in that case you won't even need to define a constructor function. So I'm going to remove the counter component, and then create a new component, and I'll name it login. And make sure to extend React component. Create a render function, and return some JSX. And I'll wrap this component in a div. And then give this component a header tag with the text login. And now let's create a form component. So I'm going to wrap the input elements in a div. And then for the labels, I'm just going to use a p tag. Add an input element. And add a name attribute, which I'll set to username. And that's it for this input element. Now do the exact same thing for the password element. Set the name attribute to password, and then set the type attribute to password as well. And finally, we need to create a submit button. Set the type to submit, and then the button text to login. Now add the login component to the app. Save the file, and let's check out the results in the browser. And as you can see, we have a basic login form. Right now, the input elements are unmanaged. And what that means is that React doesn't manage their internal state. And there's nothing wrong with this, but most of the time you're going to want React to manage an input element's internal state. It makes form validation and user feedback easier to implement. Now, if I click the login button, the browser does a GET request, and the form data is provided as query strings in the URL. So we'll want to change this as well. So I'm going to remove the query strings from the URL, and then go back to my IDE. So I'll start out by creating a constructor method, pass in the props to the super, and then create a new local state object, and define two keys, username and password. And then I'll destructure the component state in the render function. And then set the input element's value to the state variable. And then do the same thing for the password input element. And now let's create an event handler for the input elements. And you can define this as a class method and then bind it in the constructor, or define it as an instance variable and assign it to an arrow function. It doesn't really matter, the choice is yours. Make sure to provide a parameter to accept the event, and all events in React are synthetic events. And all that means is that React provides a wrapper around the native event. This provides a unified API to work with events. And since I'm defining this as a class method, I need to bind it to the instance. So when this method gets called, we need to update the internal state for our input elements. So call setState. And I want this method to work for both input elements. So for the key, I'll use the target.name. And for the value, I'll set it to e.target.value. Now we just need to add the onChange event to the input elements, using camel case, of course. And do the same thing for the password. Save the file, and let's check out the results in the browser. Click on the login component in the developer tools. And now when we modify one of the input elements, the internal state for the login component reflects that change. I forgot to mention this earlier, but if you click on the gear icon in the React Developer Tools app, and then check the Highlight Updates when components render checkbox, the browser will identify any components that update by drawing a box around them. This makes it easy to identify which components are getting re-rendered. When I modify one of the input elements, you can see that the login component re-renders. Now let's create a handle submit function. And then bind it to this instance. And then within the handle submit function, I'll call e.preventDefault to prevent the browser from sending off a GET request with the form data. And then console log out the username and password. To define the string, I'm going to use template literals. And template literals are delimited by the backtick character, which is right above your tab key. You can insert expressions within your template literals by surrounding them with the $ curly bracket syntax. And now set the form's onSubmitHandler to the handle submit function. Save the file, and let's check out the results in the browser. Click on the login component so we can view its internal state, and then add a username and password. When I click on the login button, we can see that the console prints out the user's login information. But there is one small improvement that we can make. When the login button is clicked, we should clear out the username and password fields. So go back to your IDE, and in the handle submit function, add a call to setState. Then I'll just set the username and password to empty string values. To summarize event handling in React, all event names are camel case. When attaching an event handler to a JSX-defined React component, avoid passing an arrow function or using bind directly on the component. Otherwise, the event handler will have to be updated every time the parent component renders. When defining event handlers, make sure to resolve the this variable by defining an instance property that is assigned to either an arrow function or stores the result of calling bind on a class method. And finally, all events that are passed to an event handler are synthetic events. A synthetic event is just a wrapper that wraps around the native event, providing a unified interface that works across all browsers. The native event property on a synthetic event will give you access to the native DOM event. So I'm going to remove the login component from our app, and then create a new class-based component named clock. And then add a render function, which will return some JSX. So I'll add a div to wrap around the component, and then add an h3 tag with the text current time. And then add a p tag with some curly brackets, then create a new date, then dot to local time string. And then add the new component to our app. Save the file, and let's check out the results in the browser. So our clock component displays the current time, but it's static, and it doesn't stay in sync with the time. So how can we fix that? Now every React component has a predictable lifecycle process. This process includes the mounting phase, updating phase, and unmounting phase. Each lifecycle phase includes multiple methods that you can override to run code at a particular time within this process. During the mounting phase, the first method that is called is the constructor. Typically, you'd use the constructor to initialize state and bind event handlers. One limitation of the constructor is that it cannot produce any side effects. So that means no asynchronous calls. So you cannot call set state, you cannot set up an interval or timer, and you cannot perform any network requests. Of course, you can define your component's initial state object and bind event handlers to instance methods. And now let's update the component so it uses the internal state date object. And just like before, we'll call to local time string. After the constructor function is called, the next function is get drive state from props. This is a static function, so you don't have access to any instance variables. This function receives two parameters, props and state, and it should return a new object to merge with state or null. This is a rarely used lifecycle method, and you'd use it when a component's state depends on the props that it receives. However, you cannot produce any side effects within this function. That means no asynchronous calls, no calls to set state, no network requests, and you cannot access any instance variables on the component. After get drive state from props, then the render method is called and the component is rendered to the DOM. The render method will examine a component's props or state and then return one of the following: a React element, an array or fragment, a portal, a primitive value, or null, which would render nothing. The render function should be pure, which means that it cannot modify the component's state by calling setState, and it can't perform any asynchronous work. After the render method has been called, then component did mount is called. Any initialization that requires DOM nodes should go in here. You can also produce side effects within this method. That means you can perform network requests, call setState, and set up intervals, timers, or other subscriptions. So for this component, I'll set up an interval that'll update the state every second. I also want to save the interval ID as an instance property so that I can cancel the interval before the component gets removed. So this .timerID equals setInterval. And then pass in a function to update the component state. Now just update the date key with a new date object. And then we're going to execute this function every 1000 milliseconds or every 1 second. The methods that we've covered so far are part of the mounting lifecycle process. Next, we'll look at the unmounting lifecycle. And this lifecycle is pretty simple. Only one method is called and is the component will unmount method. This method is invoked immediately before a component is unmounted and destroyed. So within this method, you want to perform any required component cleanup, such as canceling network requests, clearing out subscriptions, timers, or intervals. Do not call setState within this method because the component will never re-render. For our clock component, we want to clear out the interval that was created in the component did mount lifecycle method. So call the function clear interval and then pass in the timer ID. The component did mount and component will unmount are the only two lifecycle methods that we need to make our component work. So go ahead and save the file, then check out the results in the browser. So we've covered the mounting lifecycle methods and the unmounting lifecycle method, Between the two, we have the updating lifecycle methods. And the first method that is called in the updating phase is the getDerivedStateFromProps method, which will return a new object that will be merged with a component state or null. The next method in the updating lifecycle is shouldComponentUpdate. This method is executed anytime a component state or props change and allows you to define custom logic to determine if a component should re-render. The default behavior is for a component to re-render anytime the state or props change. Before implementing custom logic to this method, consider using the built-in pure component, which will perform a shallow diff of the state and props to determine if the component should render. After shouldComponentUpdate is invoked, then the render method is invoked, followed by getSnapshotBeforeUpdate. This method is invoked right before the rendered content is committed to the DOM and gives you a last chance to capture any information from the DOM before it gets updated. This method needs to return a snapshot or null, which is then passed to the componentDidUpdate lifecycle method. This is a rarely used lifecycle method, but there are a few instances where it can come in handy. And then finally, we have componentDidUpdate. This method will receive the previous props, the previous state, and if getSnapshotBeforeUpdate is implemented, it'll get a snapshot as well. Within this method, you can invoke asynchronous code, call setState, and perform network requests. But be aware that this method gets executed every time the component updates, so any code that you include in this method needs to be surrounded within a condition that will check the previous props or state with the current props or state to prevent creating an endless loop. Alright, so the most common lifecycle methods that you'll use is componentDidMount, componentDidUpdate, and componentWillUnmount. These are also the only three lifecycle methods that you can produce side effects in. For a clock component, the only two lifecycle methods that we need is the componentDidMount method, so that we can set up our interval, and the componentWillUnmount method to clear the interval. That is it for this video. If you like this video, then please like, share, subscribe. If you want to support the creation of these videos, then check out my Patreon page. The link is in the description, and I'll see you in the next video.